Well, good afternoon and welcome everyone to today's webinar. My name is David Godwin and I am the director of the Southern Fire Exchange program with the University of Florida. Today I'm excited about our presentation from Rebecca Ward, Assistant State Climatologist for North Carolina. Today, Rebecca will be talking about the results of the recently released North Carolina State Climate Report. And now it's my pleasure to introduce our speaker today. Rebecca Ward is a native of North Carolina and grew up in the town of Newport near the coast. She obtained a BS in meteorology and applied mathematics in 2011 and an MS in atmospheric sciences in 2014, all from North Carolina State University. As the Assistant State Climatologist, Rebecca's work focuses on understanding how North Carolina's weather and climate influences the various sectors within the state, such as agriculture and natural resources, and sharing this knowledge with North Carolinians. She's also a member of the North Carolina Drought Management Advisory Council. Rebecca also works closely with North Carolina Cooperative Extension to research, develop, and deliver climate-informed resources to support agricultural decisions. Rebecca is currently pursuing a PhD in science education at North Carolina State University with a focus on how individuals learn about and perceive risk from natural hazards. So with that, thank you all for joining us today, and thank you so much, Rebecca. Welcome. And just one moment as we trade out presentations.
Well, thank you for that introduction. I'm excited to be here today to talk. Just a brief overview of my presentation today. I'm going to talk a little bit about the background of the recently released North Carolina Climate Science Report, and then provide a little bit of a background on climate and wildfires in North Carolina, recognizing that my audience here today is probably not all from North Carolina. And then I'm going to try to spend the bulk of my time talking about the findings of the report, what does it tell us about the future, and how do we know and how confident are we, and then spend a little bit of time on where to go from here. So with that, so the North Carolina Climate Science Report, which on the right there is just a screenshot of the front page, and then the link there on the bottom will take you to the report. It's a scientific assessment of historical climate trends and potential future climate change in North Carolina under increased greenhouse gas concentrations. This report supports North Carolina Governor Cooper's Executive Order 80, and Section 9 of that report directs all cabinet agencies in the state of North Carolina to integrate climate adaptation and resiliency planning into their policies, programs, and operations. And the idea is that by evaluating the impacts of climate change on programs and operations, cabinet agencies will be able to support communities and sectors of the economy that are most vulnerable to climate change, and to protect the resources and assets that are of value to North Carolinians. So the North Carolina Department of Environmental Quality was tasked to lead this effort. And as part of this, they're working on sort of three prongs. So the first is partnering with the North Carolina Institute for Climate Studies to develop this climate science report, which I'm talking about today. They've also hosted a series of regional resiliency workshops across the state of North Carolina in the three different regions of the state: the mountains, the Piedmont, and the coastal plain. And then they're also developing the North Carolina Risk Assessment and Resiliency Plan, which is due to be published next month. So the idea behind this executive order and the different things coming out as part of it are to not stop at the science, but to actually incorporate climate adaptation and resiliency planning into the state's activities. So a little bit about the report itself. The development was led by NC State University's North Carolina Institute for Climate Studies, which is also referred to as NCICS. This is located up in Asheville, North Carolina. And NCICS facilitates climate-related research across the University of North Carolina system and its partner organizations. So they were really well equipped to lead this effort. The report itself was prepared independently by North Carolina-based climate experts. Some of them were at NCICS. Others came from different institutions across the state, including NC State University and the State Climate Office. And the report is informed by the scientific consensus on climate change represented in the US 4th National Climate Assessment, as well as the 5th IPCC report, the latest research that's been published in credible scientific journals, and then information for the North Carolina State Climate Summary. So we really tried to make sure that the report is based on the best available science today that's been peer reviewed. And it covers a variety of topics. It's definitely a technical report, but there's a lot of great detail in it, including historical trends of different climate variables in the state, projected changes in the future, and then how the impacts from climate change are interconnected across sectors. And so today I'm going to be talking about wildfires, specifically in North Carolina under climate change. And the bulk of the material I'll be sharing, I tried to make sure it came from this report to really highlight what's new and unique from this. And I did want to add that I do recognize that the audience I have today isn't solely from North Carolina. So my hope is that the presentation does provide some helpful scientific background. And where it's applicable, I've tried to include some references to the broader Southeast. And then the last thing I wanted to say just about the report framework itself are the two future scenarios that it uses for its climate model projections. So these representative concentration pathways, that RCP there, are just definitions in the future concentration of carbon in the atmosphere. So when we're talking about different scenarios, we're talking about how much carbon we're expecting to see in the atmosphere in the future, and that's based on human activities. So the North Carolina Climate Science Report uses two different scenarios. So the first is a higher emission scenario, that's RCP 8.5. And so under this scenario, greenhouse gas emissions continue to increase through the end of the century. This is also sometimes referred to as a business as usual. And then the second scenario is RCP 4.5, so this is a lower scenario. Under this one, through the middle of the century, we do continue to see increasing emissions, but at a lower rate. By the middle of the century, they kind of flatten, and then they start to decline at the end of the century. And so based on the available evidence that we have, both of these scenarios are possibilities for our future, so they do make a lot of sense to be what we're looking at in this report. All right, so with that, I'm going to transition just to try to do a really quick, brief overview of North Carolina's climate. I am a climate scientist, so this is what gets me really excited, but I'll try not to spend too much time on it. So North Carolina, our climate, and this is really going to be kind of applicable to a lot of places in the Southeast United States too. So the first is, location is everything that really drives our climate. We're situated at about 36 degrees north. That gives us a nice temperate climate. We have warm, humid summers, fairly mild winters, but we do see winter. The Appalachian Mountains to our west protect us from the intensity of many of the weather systems that move across the country. So we might still see, a lot of rain and storms from them, but they will a lot of times lose that energy before they make it to much of the state. And then finally, the proximity to both the Gulf of Mexico and the Atlantic Ocean provide us with an influx of moisture, like a lot of the Southeast. We do have a temperate climate. We do see our lowest temperatures kind of around mid to late January, and then our highest temperatures are typically in mid-July. Obviously, this will vary on any given year, and we do, this line is just kind of a drawing. We do see a lot of variation in our temperatures, especially in the springtime. We typically spend more than half the year free of frost, and that has been increasing over the past few decades. But again, our winters are typically fairly mild, so even though the frost-free season might be about 64% of the year, that winter period is not entirely below freezing. We still see quite a few days or even weeks-long stretches of above freezing temperatures. Our precipitation, we see about 40 to 50 inches of precipitation annually. Just kind of zooming in on North Carolina there. We see a little bit more along the coast just due to tropical activity, and also a little bit more in parts of the mountains due to the terrain effects. And it's a fun fact for me that the driest and wettest places in North Carolina are actually only about 40 miles apart in the state. and they're both in the mountains. Just a couple more slides on North Carolina. And so we don't have a wet or dry season in the state. I just tried to show the, for a couple of different locations, how their precipitation accumulates throughout the year. It's pretty linear. We see precipitation year round, but exactly how that precipitation falls does vary throughout the year. So like a lot of places in the southeastern part of the United States, our precipitation in the summer is generally very localized. Think of your afternoon thunderstorms. On any given day, we might expect a few places to see storms, but over the course of a week or month, typically most places in the state will see about the same amount. And we average about 3/4 of an inch to an inch a week. Over the winter, larger patterns dominate our weather. So these are like your cold fronts and warm fronts. So if you were to look at the 7-day forecast, you might see a couple of days in a row with high probabilities of precipitation, and then the whole state's likely to see something. So our weather in North Carolina, we see a lot, and so does the southeastern United States. And we see all of the impacts, from rain and snow to thunderstorms to, like today, tropical weather as well. And we also see wildfires. These are definitely a part of our climate. So the state, like much of the Southeast US, historically experiences wildfires. And a lot of our native ecosystems are adapted to that. Over the past 100 years, we've seen an increase in the number of wildfires in North Carolina annually, but a decrease in the acres burned. And a lot of this isn't climate related, it's just due to management activities like prescribed burns. Typically, the wildfire potential is at its highest in the fall after vegetation has become dormant, as well as in the spring before vegetation begins growing. And in fact, as of about a week ago, we finally had green up across the whole state, so that's lowered our risk for wildfire substantially. So has the tropical storm today. There are a lot of year-to-year changes in the number of wildfires and acres burned. And this variability is influenced by a number of climate and non-climate factors, like I mentioned before, just the management activities. One of those climate factors, though, are droughts. We don't need a drought to get a wildfire, but large fires and years with high numbers of acres burned have been associated with droughts. So let me transition now to thinking a little bit about the future of drought in North Carolina. So at global and national scales, climate change has already increased the frequency and severity of wildfires. And in the southeastern United States, the length of the fire season and the average land area burned by wildfire are projected to increase. But wildfires, because they're influenced by so many climate and non-climate factors, it's difficult to project exactly how they will change into the future. But to get a sense of future climate conditions and how these might influence that, we can look at the different atmospheric variables that influence that likelihood of wildfire. So the variables that influence wildfire likelihood are precipitation, temperature, atmospheric water vapor content, incoming solar energy, and wind. So I'm gonna try to unpack these a little bit more, looking at these individual climate variables from the North Carolina Climate Science Report. And I will have a couple of graphs and maps from the report. I try to avoid too much technical information here, but I did think it might be helpful. So I'm going to start with precipitation. Okay, so based on the historical record for North Carolina, there hasn't been an observed trend in the annual precipitation in the state. But projections are for the total annual precipitation to increase by the middle of this century. So over the next 20 years, that's highlighted in this box here on the left, both the low and the high emission scenarios are projecting overall small increases in the total annual precipitation, about 0 to 3% increase. And this is shown here on the left for the higher scenario. Both the lower and the higher scenario for the next few decades are very similar. So it's just in the report and in my presentation, just easier to show this scenario only. But for the later in the century, we do show both lower and higher. So that's what's here on the middle and the right. looking at the 2041 to 2060 time period, how is our precipitation projected to change? So the lower scenario, that middle map, we're projecting only a slight increase, kind of similar to what we might expect over the next 20 years, whereas that higher scenario is projecting about a 3 to 6% increase over a lot of the Piedmont and into the mountains of North Carolina. But our precipitation, like I had shown before, doesn't always fall the same way. It varies throughout the year. In particular, extreme precipitation events were something that this report looked at to see how those are changing. So these are defined as days with precipitation of 3 or more inches. And over the historical record, the number of these events varies quite a bit, but there is a statistically significant upward trend in the number of extreme precipitation events over time. And the highest number of those extreme precipitation events have occurred in the last 4-year period of the record. So we're seeing a lot more of these events. And the physical mechanism behind this is that under a changing climate with a warming atmosphere, a warmer atmosphere can hold more water vapor. And so that therefore has more water vapor that is available to increase these heavy rainfall events. So projected changes into the future, I'm using that same, the same order of maps as I used previously, are that for both low and high emission scenarios, suggesting increases in the number of days with precipitation of 3 or more inches. For the next 20 years, the map on the left, and then the 2041 to 2060 period with the 2 maps on the right, you can see sort of some subtle differences, but overall showing an increase in the number of days that we're expecting. So the takeaway is that there is a virtual certainty that the amount of water vapor in the atmosphere will increase, which is going to make it very likely that the risk of extreme precipitation will increase everywhere in the state of North Carolina. So our temperatures, we do have a little bit more consistency and confidence with what to expect in the future than our precipitation. Globally, surface temperature has increased by about 1.8 degrees Fahrenheit since the start of the 20th century, and it's continuing to rise. And since 1895 in North Carolina, the statewide temperature has increased by about 1 degree Fahrenheit. And since the 1990s, they've been consistently above normal as well in the state. And in particular, the summer average temperatures have been the warmest on record over the past 14 years. And the top 3 warmest summers also occurred in that period. So we have a pretty compelling and consistent picture that we're warming in the state, as well as globally. And so this is just a graph from the report showing what those projected changes are into the future. So the observed climatological value for the annual temperature over the reference period that we're using here, 1970 to 2013, is that black line. And it's just a line drawn. We didn't have flat temperatures during those years, but just to show you what that average looked like. The gray line kind of behind it shows the simulated historical annual average temperatures for North Carolina. And then the red and green shaded areas are projected changes for 2006 to 2100. And you can see that the 2 scenarios are quite similar for the next few decades, but then they start to diverge as we get into later in the century. So by 2050, models project that the annual average temperature in North Carolina will increase by about 2 to 4 degrees Fahrenheit under a lower scenario and about 2 to 5 degrees Fahrenheit under that higher scenario. But once we get towards the end of the century, the lower scenario projections are for an increase of about 2 to 6 degrees Fahrenheit, while the higher scenario is for about 6 to 10 degrees. So again, they really do diverge once we get to the end of the century, which is based on what humans do. Our temperatures aren't warming at the same rate in everywhere. So in particular, looking at warm nights, so, or very warm nights rather. So this is defined as nights where the temperature is at least 75 degrees Fahrenheit or warmer. And the number of very warm nights during 2008 to 2017 is higher than during any other consecutive 10-year period in the state. And we are seeing an increasing trend in these very warm nights. And future projections are for increases in the number of very warm nights in both the Piedmont and the coastal plain, but not really in the mountains of North Carolina. So you can kind of see that here, that we're really not expecting to see much of a change in the mountains of the state, but particularly when we get to the higher scenario, we're expecting to see quite a few more warm nights over quite a bit of the state of North Carolina. And then on the flip side, we have very hot days. So these are defined as days where the temperature is 95 degrees or warmer. So in our historical record, there is not a trend in the number of very hot days, but future projections are that we will see more very hot days into the future. Because these projections aren't consistent with that historical trend, we do have a little bit less confidence, but because we are expecting to see warming temperatures in the state, it's still likely that the number of very hot days will increase. And this is what the projections are showing. By 2021 to 2040, little or no change in the mountains, but we're expecting 10 to 20 more days per year in the Piedmont and the coastal plain. Mid-century, those two maps in the center and on the right, under both scenarios, projections are for increases everywhere in the state. And there's quite a bit of a difference between the two, with the lower scenario, increases of 10 to 15 days in the mountains, and 20 plus days elsewhere. That's that middle one. And then the higher scenario, 10 to 15 days in the mountains, and then 25 or more days across much of the Piedmont and the coastal plain. So definitely a big difference, expecting many more very hot days across the state. And then we can start to get into, not just looking at temperature and precipitation, but how those might interact. So a lot of my background has been looking at droughts in North Carolina and across the Southeast. And so thinking about droughts in the future, because there's not a lot of confidence in exactly how that future precipitation might change, it's challenging to make projections or issue a confidence on future drought likelihood. But we are projecting that future droughts will be warmer than their historical equivalents with a pretty high level of confidence. And that's because we're very confident that our temperatures will warm. And so because of this, it's likely that future droughts will be more severe in terms of soil moisture deficits and the impacts on rain-fed agriculture and natural vegetation. So all else being equal, because it'll be warmer in the future, we're expecting that future droughts will be more severe than they have been in the past. And so from our historical record, and we don't really have to go back very far, 2016 being a pretty notable example, we know that severe droughts can increase the intensity of wildfires and lower the availability of suitable conditions for prescribed burns. So that's definitely something to think about. So I know I threw just kind of a lot of graphs and things about just different weather parameters out there. So I do want to pause for a second and come back to this slide on the atmospheric variables that influence the likelihood of wildfires. And then come to some of my takeaways for future North Carolina climate. So across the Southeast, future changes in precipitation, our annual precipitation, are uncertain, though there is pretty high confidence that temperatures are projected to increase. And increasing temperatures will increase regional drying. And a consequence of this is that forest water use via evapotranspiration will increase, which will lead to drying, which can increase the wildfire occurrence in forests across the region. And future projections for the number of weeks with conditions conducive to very large fires suggest substantial increases in the coastal plain, but we don't have as much information about the mountains in Piedmont. Our future droughts, we're expecting that they will be more severe than their historical equivalents, and we do know that that can increase the intensity of wildfires and lower the availability of suitable conditions for prescribed burns. So when I think about climate change, it's not that it's going to bring us any brand new weather or weather hazards that we haven't experienced before. It's more that it's kind of turning the knobs and playing with the dials and altering how different things interact than maybe they have in the past. So for example, like I had just mentioned, our best understanding of the future is that droughts will be more severe than their historic counterparts, driven in large part by the projected warming in temperatures. And while our precipitation amounts are projected to increase a little annually, in the summertime, we're expecting more of that precipitation to fall and heavier events. And we are also expecting to see that those heavy events might be interspersed by more dry days. And so for forests, this means increased evapotranspiration during those dry times. And then when it does rain, some of it will infiltrate the soil, but more of it will also run off and not be available. So then if we can add a drought to the mix, it can increase the intensity of wildfires. And droughts, even without any fires, can lead to tree stress and in severe cases, tree mortality. And this can open the door for pests or invasive species to move in, which can do more damage, further weakening individual trees and forests. In turn, that can alter the availability of fuels for burning and wildfires. So a lot of these factors, which were previously already interacting, in the future might be interacting in kind of a more extreme manner than previously. And then we also have some other compounding factors to think about too with our weather in North Carolina and across the Southeast. So consistent findings from the literature that's being done to research hurricanes under a changing climate are that the strongest storms are expected to become stronger. And associated with this, there's medium to high confidence that there will be increases in their impacts, namely damaging winds and storm surge. There is less consistency among research studies on how the frequency of hurricanes will change, let alone about landfalls and near misses in North Carolina or any other specific location in the US. It is likely that hurricanes in a warmer environment will produce heavier precipitation, just again, because if the atmosphere is warmer, it has the ability to hold more of that water vapor. And so while global warming is likely to lead to heavier rainfall rates in hurricanes, there is no scientific evidence that future landfalling hurricanes are more likely to slow down after landfall. That's still an area of active research. So when we think about hurricane damage and hurricanes themselves, they're not going away. They're going to continue to be part of our climate, and especially the types of damages that they can bring to not just homes, but also to forests as well. And then the last thing I wanted to talk about was the wildland urban interface. Just thinking about in the context of the changing climate, we also have changing land use patterns. So the wildland urban interface is the area where human development meets and intermingles with undeveloped land, forest, or vegetative fuels. And communities in the wildland urban interface are at an increased risk for damage from wildfires. In North Carolina, according to the North Carolina Climate Science Report, and the North Carolina Forest Service has more acres in this than any other state in the country. And that acreage is increasing each year. So as urban expansion continues and development pushes farther into places that were previously undeveloped, the opportunity for prescribed fires may be reduced. That can have the result of increasing the occurrence of wildfires as well as its associated health and economic impacts. And I did just, I went to the Federal Fire Occurrence Map Bureau. I was trying to find a recent image of the spatial coverage of the wildland urban interface. This was just a map showing it for North Carolina. And indeed, there is quite a bit of the state covered in that. So where to go from here? This is a lot of data and a lot of things are changing. And I know it takes, for me, even a lot of time to think about how to go from the science to now, what do I do? And my job is definitely not as much working with the decision making, except in the context of trying to provide that science to be informative. But I did want to share some resources that are available to think about climate adaptation planning in the context of forest management and wildfires. So the first one is the Adaptation Workbook. It's a climate change tool for land management and conservation. It's free to create an account online, and it provides a step-by-step process that's designed to help you consider how how climate change might affect your land management and conservation goals. It helps you develop a custom plan that fits what you're trying to accomplish and achieve. And so you enter information that matches your own management goals, and then the tool helps you step by step to think critically about potential climate change impacts, to identify management actions, and then to help prepare for the future climate change. Another resource that's been around for about a decade is the Template for Assessing Climate Change Impacts and Management Options, or TACMO. This provides forest land managers with information from peer-reviewed literature, and it was just updated with the most recent literature. It's sort of a one-stop shop for peer-reviewed literature, so you don't have to go out to a bunch of different resources, which I always find a daunting task when I'm trying to put together information or just kind of get my literature review together to understand a specific context or information. So it's really helpful. And the other thing that I find really useful about this, if you haven't used it, is that the findings from the articles are synthesized for you. So you can read the abstracts, and you can also kind of read this bulleted list of what the key points were. So you don't have to kind of dive down and get that yourself. It makes the job a lot faster. So I highly recommend TACMO. And then there's also just kind of more of a more general information, but still really helpful. The Eastern Forest Environmental Threat Assessment Center. So if you go to that website, you'll find quite a few fact sheets for a variety of topics, including invasive species, climate change, severe weather. They're useful starting points for thinking about climate change, kind of wrapping your head around it. But I did find it really useful if you scroll down to the bottom of that page, you'll find a breakdown by region. And under the Southeast is a new fact sheet on assessing the potential effects of climate change on national forests in the southeastern United States. That's what I have a screenshot of on the the left side of the screen. It's pretty high level, but I did like that it had some good ideas for different responses to maintain things like forest health or different plant communities or animal communities. And then coming soon, so as I mentioned in the beginning, what I was covering today was definitely that technical scientific results from the North Carolina Climate Science Report, but there is the North Carolina Risk and Resiliency Plan that's coming out, and this is to connect the science to the now what do we do about it. So look for that. North Carolina Department of Environmental Quality's website's right there, so that's kind of where the announcements will be. And then there's also a Forest Landowners Guide to hurricane preparedness and recovery. It's a guide to building resilience, preparing for and recovering from hurricane impacts. It'll include guidance that encourages forest planning to improve resiliency to hurricanes with some connections to climate change. So that should be on the USDA Southeast Climate Hub's website in the next month as well. And that is actually the end of my presentation. I know I left plenty of time for questions, so I will pause there.
All right, well, thank you very much. Once again, if you joined us during the presentation, my name is David Godwin, and I am the director of the Southern Fire Exchange with the University of Florida. And the presentation that we just saw was from Rebecca Ward with the North Carolina State Climate Office, talking about the recent North Carolina State Climate Assessment and the implications for wildland fire in the Southeast. So we have time remaining in our program today, and this is the opportunity for you to ask questions. So please type your questions and comments into the Q&A window in Zoom, and we'll try to get through them in the time that we have remaining today. So I'm going to switch right over here. And here's a question that came in. The question is, could you talk about the impact of burn scars, of wildfire burn scars on flooding and losses in North Carolina?
That's a really good question. I'm not sure exactly what that economic loss is. I do know that there's a connection between burn scars and increased erosion in the future, especially under a changing climate, if we're expecting to see more of that with heavier precipitation events. But I'm not aware of any economic studies that have been done on that. But I'm not aware of it, but that doesn't mean it hasn't been done. I'll make a note of that too. Yeah.
There's quite a bit of work on post-fire flooding and soil loss and movement from the western U.S., but I'm not aware of much research on that in the Southeast. Here's another question that came in, and the person asked, how much does smoke from wildfires in the Southeast impact air quality? And how long does it take for the air quality to return to healthy or more background levels? So maybe you could also talk about or mention, how often in North Carolina do you see that change in air masses across the state?
Sure. Yeah. So we definitely do see effects from air quality during wildfires, and the 2016 wildfires that we have are a really great example, or I guess bad example of the impacts of the air quality. There's lots of pictures that when I was just trying to find stock photos for this, that came up from then, that with the hazy sky in places throughout the mountains, and even all the way as far east as east of the Raleigh area where I work. So yeah, we have quite a few impacts from there. Really, it takes just a changing weather pattern, as David mentioned. So typically weekly, we can cycle through different air patterns. In the summertime, we might have kind of the stagnant, still air mass settle in over the southeastern United States, a high pressure system, and that'll move on over timescales of a couple of days. So typically we'll see about once a week a new weather pattern, at least once a week come along that'll move that out.
We had a question come in from Bill in the chat window, and Bill is asking about the predicted increases in precipitation at the same time that we're also expecting to have increases in drought. Could you kind of unpack how those two things work together?
Yeah, so in the summertime, having warmer temperatures, that increases the atmosphere's ability to hold on to water. If you think about the wintertime versus the summertime, if like today, if we have 80% relative humidity and you walk outside, it's a lot more humid, palpable, almost how much moisture is in the air than in the wintertime. And that's just because the air is warmer. So what that also means, though, is the way our precipitation patterns might shift a little bit. So already we might have days that are conducive to storms developing, and then days that we might see some of that development happen, but it doesn't quite get to the point where it can rain out. So really it's a matter of the atmosphere can hold more water. So when it finally, lets go of that water in the form of precipitation, a lot more is going to fall at a single time. But then it might also just be that the ability to get to that point where it does precipitate is going to take a little bit longer to happen. So that's why I might see more days between rainfall events, but then when it does rain, heavier rainfall.
And another question that came in asking about increases or decreases in cloud cover due to higher moisture levels or temperatures. Do the models or forecasts go talk about cloud cover changes?
Yeah, that's a good question. And I've seen some things come across studies of climate change looking at changes into the types of clouds you might see, like seeing more cirrus clouds. I don't actually know though how that might change for the southeastern United States. How we might, if we might expect to see, maybe more days with a haze, or more days with kind of your lower kind of stratusy clouds. So I don't actually know the answer to that, but I do know that climate change does alter clouds. So it's a good question.
Here's a question that came in asking about changes in wildfire activity in North Carolina. Do you have resources on changes in wildfire activity that have already been observed within North Carolina?
So the best resource I found for looking at North Carolina wildfire information is from the North Carolina Forest Service. It seems like it's really hard to pick out exactly what's just management versus what's due to climate change. There was one study, and I can send out the author that I encountered, and it's referenced in that climate science report as well. That was trying to look at how wildfires might change into the future. What would that likelihood be? What would the probability and the acreage burned? And they did use modeled historical data, so that might be a good resource to think about that historical information.
Here's a question that came in from Jonathan. Jonathan asks about confidence intervals in the model outputs, and more specifically, Jonathan's asking about what are the areas of the greatest weakness or uncertainty in terms of the model output. So maybe phrasing that with what we saw today, are there things that we have the least amount of certainty within in terms of predicting climate impacts in the region?
Yeah, so I'll kind of think about that in two different ways. So our climate models have within them, some sources of uncertainty. So one is just they're based on the atmosphere, but they're sort of numerical approximations. So they're the inability to get every single second of the day or every single grid point, just computational limitations. There's some biases that can occur there. There's also just the natural system. We're pretty good at getting our understanding of the climate system, but there's just still some internal noise in the system, some things that we don't understand. So there's that. And the other source of uncertainty moving in the future is exactly what will humans do. So all of these do factor into what we can project with certainty into the future. But then the other thing is, I guess, kind of relating to the second and third, our understanding of the climate system and our understanding, our ability to predict what humans will do. Things like precipitation, those are already difficult things to capture in the Southeast, just because, especially in the summertime, processes are so localized. We don't have a lot of big climate signals that we can use to predict what will happen. I mean, even now, thinking about the summertime, knowing exactly what our precipitation will be 2 months from now is really difficult to tell in any sort of trend. And I know that, a 2-month forecast is very different than a global climate model output projecting 20, 50 years into the future. But the idea that we have a lot less certainty on things like precipitation than we do on things like temperature. We're a lot more confident in how our temperatures have changed and how they will change in the future.
Here's a question from Patrick. Patrick asks, with a projected increase in temperature and precipitation coupled with increased drought severity, could that result in an increase in vegetative growth and then subsequent dieback due to the drought, facilitating sort of a feedback for wildfires?
Yeah, I mean, that's definitely a possibility, right? How our plant structures change in relation to seeing warmer temperatures earlier in the year, if they'll go through a drying out signal in the summertime, or just kind of complete their life cycle early. That's definitely a possibility. And I think the difference might be that we still expect to see, a winter. So at least on an annual basis, we should hopefully get a nice reset. Yeah, but no, that's a very good point about the factors that can compound together and increase that likelihood or severity of wildfires if they do occur.
So here's a question kind of pivoting to prescribed burning that came in. And the question is, the recent models projected for the next century seem to indicate that prescribed burning will be less available due to the prevalence of drought. So what do you think are the projected impacts of the loss of opportunity to use prescribed fire in North Carolina?
Yeah, that's another really great question. And I think it might be getting outside of my expertise area a little bit. I think what it's going to take is approaching this, from there's the climate side, what's the availability that we're going to have now because our climate system is changing and the periods where the weather is conducive are changing. But, thinking about like the wildland urban interface, also that the available land where we can do prescribed burns might be changing, ways to alter the public perception to get people on board with prescribed burns in a safe way. That might be where the future has to go, and thinking about that. And I'll say that's just kind of my take on it. That's, I don't know if that's the right answer, but I do think it's going to take more than thinking about it from that climate angle, trying to think about the sort of public policy side of it as well.
So this is my question. So this is the North Carolina State Climate Report. Are there other states that you are aware of that are working on this at a state level and are putting together plans or resources to prepare for climate change, especially from a natural resources or fire perspective?
Yeah, so I know there's been a lot of work done in the Western United States, and I know that a lot of, there's a lot of local groups and regional groups that are working on, climate change research and reports that are more of a sector-specific nature. I'm not aware off the top of my head of any other states, particularly in the Southeast, that are coming out with reports, but I do hope that as this becomes more normal, that more states do this, that it might be seen as a template for other states to do as well. I think that your national reports, like the National Climate Assessment, if anyone has read through that, are really fantastic and really present a great national and regional perspective on what's going on, kind of a great big picture. But having these local reports, especially that are authored by local scientists and take into consideration the concerns of people really on the ground, have a lot more potential to impact what happens at that local level. So I do hope it leads to some future changes and some other states doing this as well, if they're not already in the plans for that.
All right, well, thank you. We're going to change screens real quick here and put up the contact information there. All right, well, it looks like we have come up about to the end of our webinar today. So thank you so much, Rebecca, for your presentation. Thank you everyone who submitted questions. If you have additional questions or would like to follow up with Rebecca about any of the resources that she shared today or about the report, you can see her contact info on the screen. So with that, thank you everyone for joining us today, and thank you especially, Rebecca, for your presentation. I really enjoyed it, and I hope you all have a good afternoon.